Why is taking the mod of a number in Python faster with exponents? I was trying to optimize a program I'm tinkering with, when I noticed that doing value equals I%65,536 appeared to be running slower than doing value equals I%216. To test this, I ran the following program. Which produced the following output. Using 65,536 was the slowest at 10.466 seconds, while doing 256.2 was the fastest at 7.475 seconds, with the other possible exponent values falling in between. Granted, this difference in speed is only noticeable given high amounts of repetition, but I'm still curious as to why this occurs. Why is taking the mod of a number by 65,536 slower than taking the mod using exponents? They should evaluate to the same number, and I would have thought that it would take longer for the Python interpreter to fully evaluate exponents before taking the mod. By extension, is it generally more efficient to use powers of 2 in Python expressions rather than fully typing the number out? And does this pattern hold true for operations besides modulus or for other numbers besides 2? BTW, I'm using Python 2.7.2, 32-bit, and I ran the above on a 64-bit Windows 7 laptop. Edit. So I tried reversing the order of the functions I call, and now the opposite is true. It looks like whatever the first function is in run_tests will always run a bit slower when using profile, which is weird. So, lesson learned, I guess, profilers are weird, D.
There is no difference in the generated bytecode, because the compiler does its job well and optimizes away the constant arithmetic expression. That means your test results are just a coincidence. Try timing the functions in a different order. Well, actually there is a difference. The number is stored at different offsets in the constant table. I can't imagine this causing any difference, though. For completeness, here's a proper test that uses the timeout module. Note that I am measuring the minimum time needed, rather than the average. If it takes longer for some reason, this just means that it was interrupted more often, because the code doesn't depend on anything but the power of your CPU.
Using dist to show the Python bytes code shows that the functions are identical. Python has optimized the constant, as expected. So I suspect the time differences are caching effects. The timings on my laptop bear this out, using Python 2.7.3 64-bit on Linux. All pretty much identical.
You have run every test only once. The speed of your CPU isn't the same all the time. At the start of the test it was most probably sleeping, and that's why the first test was slower. For benchmarking small parts of code, like mod, use timeeat module. You can see that the average is always around 0.864,